Hello, we're Soul Margin Fishing and Conservation Foundation, and welcome to our channel. Come join us here every Sunday for Soul Sunday, where we release new videos. Please donate to our cause and subscribe now.
Hey everyone, how you doing? My name is Captain Sam, and I want to welcome you to the Soul Margin Fishing and Conservation Foundation webinar tonight, talking about Fish ID. I'm super excited about it. I'm super excited to have our speaker back again. He did a webinar with us last year, and it was an amazing time. We built our friendship over that time, ran into each other a couple of times, and we're trying to schedule a time to catch up with each other in South Florida to go out and hunt some fish and do some amazing things. So if this is your first time to our webinar, welcome. If this like your second or third time, again, we love having you back. We love having you. You are a family, and we love having you at our webinar. So one thing I want to put out there, as we do the webinar, you'll have questions that come up, right? We'll have a Q&A section at the end of the webinar. But what I want you to do is I want you to put your questions in the chat while you watch the webinar, because I promise you're going to have some questions that come up, and it's going to be a lot of good learning, especially when it comes to fishing and becoming a better fisherman. So I'm not going to waste time. I'm going to go ahead and introduce our speaker. His name is Mike Sipos. He is a Florida Sea Grant agent down in Collier County. That's down in Naples, if you don't know where that is, the Naples area. And he's a really good person. And as one of our friends said, who we had on a webinar before, he said that this guy's legendary. Yeah, this is a legendary guy. So I'm not going to waste any more time. I'm going to head and bring him in, and then we'll get going. So here we go. Hey, Mike.
Hey.
It's always a pleasure to have you, man.
Cool.
Yes. Clark said you're legendary, man. We talked about this before. You guys are doing some good things together. So I want you to tell them a little bit more about what you do, and then just go into your presentation. So again, thank you for being here. So I'm gonna let you take over, okay, Mike?
Sure. Can everybody hear me just great? Okie dokie. So my name is Mike Sipos. I am a Florida Sea Grant agent in Collier County, like Sam mentioned. So we are part of the UF IFAS Extension Service. Each one of Florida's 67 counties has an extension presence where there's a UF expert in a particular field. They're waiting to answer your questions. So we have about 20 Sea Grant agents scattered throughout the coastal counties of Florida. However, if you're in the middle of the state, there might not be a Sea Grant agent, but there might be like a cattle or a livestock agent there, just depending on what are the needs of the local communities. So we bring science-based information to help increase knowledge, behavior change, skills learned, and conserve natural resources. So a lot of my programmatic area is actually in sustainable fishing. So we teach, fish IDs, best practices. I do a lot of invasive species outreach and education, some marine debris work and habitat restoration, and citizen science programs. Other agents throughout the state might focus on different topics just depending on what's really relative in your area and what their subject matter kind of background might be. So today we're going to go over fish ID from head to tail using external characteristics to better understand fish. So fish, evolved to not overcome gravity, but drag really. So water is 800 times more denser than air, 50 times more viscous than air, and has a 95% reduction of oxygen carrying capacity. So pretty much these fish have had to evolve some pretty unique characteristics from all the places they live to function. So we can use those characteristics, those external characteristics, to better understand where they fit ecologically, whether they're prey or predator, what their feeding type is, how they move. And that relates to being a better angler, because if you know how they move and what they eat and where they eat, you can really adjust your fishing approach to be better at, targeting a particular species, whether it's here in Florida or throughout the world, because, there might be a similar kind of ecological niche just based on how a fish looks. So, if a fish sort of looks like a grouper here, if it's a fish as a grouper here and you're good at catching grouper here and you go to Australia, you might be able to utilize those same techniques and tailor it a little bit based on how that fish looks. And then more importantly, this is a great kind of skill to learn and characteristics to pay attention to better identify your fish. Fish identification is essential when you're going out there fishing to prevent you from harvesting a fish that might be closed, based on regulations to help conserve our resources. So the basis of fishing is pretty much knowing what you're catching so you can determine, we got to get it back in the water ASAP, or that might be your next meal. So this is one of my favorite quotes over here as a zoologist, which is structure without function is a corpse and function without structure is a ghost. And that pretty much means that everything evolved for a reason. So why a fish is shaped just that certain way or that feeding type is because over millions of years that was advantageous and sort of outcompeted its other kind of conspecifics, other kind of species in the area. And if there is structure without any kind of function, the way you can describe why that's important would be probably sexual selection rather than natural selection. While that feature doesn't help them survive, but that feature increases the chance of them reproducing and then sharing and spreading that gene. So that's a really cool kind of concept to reflect on. So this talk has evolved in many different ways. At first, I gave it to people who are really just interested on like the diversity of fishes and their background and sort of those different features to pay attention for and just the neatness of that. But then, we gave this to local angling clubs that needed the fish identification, and even FWC, who uses that for their work. So we're going to talk about, head shapes, body tails, biological and environmental conditions, tips, best fishing practices, and questions on other kind of programs. But beforehand, we're going to sort of look into key characteristics to consider or not consider and some examples of some fish that you might have seen in Florida and how that can like reflect on that. Let's go ahead and get started. Whoops. So the diversity of fish. Fish have been around for over 530 million years. A lot of characteristics that we just see on like terrestrial things on land, came from the sea. Before fish, there weren't really vertebrates out there. It might have been just a primordial soup ocean with a bunch of things that looked like giant brine shrimp floating around or seashells. But then fish, evolved, and that might have been some of the first kind of critters to have hemoglobin, which is that red containing oxygen pigment in our blood. While a lot of like those invertebrates might have open circulatory systems and use copper for that. So we have to thank fish for a lot of cool evolutionary characteristics, including stuff like jaws. jaws evolved in fish, and there's actually not jawless fish. They call them agnathans, and you could think of ones like hagfish that look like slimy eels, or lampreys that look like, I don't know, like a pipe cover that has this like razor blade mouth, and they look really creepy from the bottom. They're up in the Great Lakes, but from the sides, they look like an eel and a fish had a baby. But they live in super diverse habitats, from like acidic or really super alkaline puddles of water to Arctic seas to the open ocean. So there's a lot of really cool features that we can look into fish and just sort of get inspired of like how nature really works. Over half of the current vertebrate species on Earth are fish. So there's about 55,000 vertebrate species out there, and about 27 to 29,000 species of fish. That number ranges because, what is a species? If there's interbreeding between two different species, is that one, or is that just like a locale or kind of variety of one? So now with genetics, we're getting better at determining individual populations versus species. And that's something that's going to be really neat to pay attention in the future. So they come in all shapes and sizes. We have the cartilaginous fish, so those are going to be your skates and rays, and there are about 970 cartilaginous fish. There's the ray fin fishes. That's probably the biggest group out there. There is the no, that's a non-teleos ray fin fishes. Teleos is a big ray fin fish group. These are the more primitive ones, like paddlefish or bikers that you might have heard of. Then we have the coelacanths, which is super primitive. They call those tetraploids or sarcopterygii instead of actinopterygii. Really, really big words, but these are a small group of fish that have sort of paddle-like almost hands instead of fins that have those rays coming out and webbing in between. Next up, we have lungfish, which is one more step on coming on land, where they can have, resist being dried up and form these like lung sacs and can breathe surface air. And then there came us, stuff that lives on land. So it's that great adaptations of great showcase of adaptations and evolution. So there are fish that lay eggs. There's fish that have internal eggs. There's fish that have placental connections, like a human. Some sharks and some rays have that, but most fish, if they have live babies, are going to be internal eggs that hatch. Same thing with like snakes that you might see, like boa constrictors that do that. There's fish that can air breathe, because what is a fish? Some people might say they have gills. Well, they have gills for sure, but some fish utilize those more than others. Fish like tarpon actually have a modified swim bladder and can gulp air on the surface and use that for air instead of, getting that from the water column with their gills, which they also do a little bit. They can be dried up. Some of them have modified fins, like the remora, like a sucker kind of top, which is a modified dorsal fin. Some have modified teeth, like the sawfish that have them on the outside of their rostrum. Bioluminescence, actually glow, like an anglerfish, or biofluorescence, that actually sort of reflect light with UV light. So think of those glowfish you see in the aquarium stores. Other ones have lures, like the anglerfish, crazy colors, cryptic coloration, antifreeze proteins. Some are warm-blooded. Some can live for hundreds of years, like the Greenland shark or some rockfish in the Pacific Northwest. Other ones are saltwater, some are freshwater, some can go between salt and freshwater. Some can change from male to female, some can be male and female at the same time. Some can basically clone themselves, called parthenogenesis. There's bonnethead sharks that can do that. Some are parasitic males that are like an anglerfish, electric mussels like the electric eel and torpedo rays, and more. So these are all cool, unique characterizations or sort of morphology that you can use for identification or just reflect on how neat fish are. So cold reading a fish, when in doubt, check them out. You can learn a lot just by looking at a fish. So like I said, everything pretty much evolved for a reason, and if it doesn't really make too sense, the reason might be the female fish liked that more, and they got to create more babies, and that gene got passed on. So looking at all these unique characteristics, especially ones that aren't really shared between a lot of different species, like chin barbels, are aids in species identification and helps predict what they eat, how they eat, and where they sort of swim. Which, if you know all those, that's pretty much what you need to be a successful angler. Some are generalists where, their fish, their mouth might be on the bottom, or their mouth might be on the top, like a tarpon upturned mouth, but they'll accept the bait off the bottom too. Some have multiple strategies as well, even almost depending on, their life stages that they might be in. So there's a lot of trends between species, like I mentioned, that you can use this kind of information if you're just around the world and encounter a fish that looks like a fish that's back at home, and trying to put two and two together on that ecology and where they live. And a lot of people are already doing this if you're an angler, whether you know it or not. So when you're fighting a fish on a hook and line, and that fish is running and it's taking a long time to pull in, what are people trying to do during that process? A lot of times they're trying to guess what kind of fish that is, right? And by guessing what kind of fish that is, you're almost trying to guess those symptoms that resulted in that these external characteristics resulted in, right? So if that fish is running really fast and really, really far, it's probably not going to be a fish that looks like a dinner plate. It might be like a torpedo-shaped fish. So what kind of fish are you targeting that can run really fast and far? If it's that pulse movement and feels really heavy, it might be a fish with big lobed fins. So what kind of fish is that? Maybe a grouper kind of species. If that fish is running towards the surface, it might be, a pelagic kind of species rather than one that lives on the bottom. So, I'm giving you the tools to sort of reflect on when you go fishing and how a certain characteristic might be more advantageous in the environment, and how you can use that next time you're out on the water. So, things to consider for a positive ID. There's a lot of words on this page, and I don't really like slides with a lot of words, but obviously the best is DNA. The average person out there fishing is not going to be able to do that. But things to really look for are stuff that doesn't really change. So, stuff that can change, which are the worst, are probably color. Fish can change color because they have pigment-containing cells called chromatophores that open and close, and they're like umbrellas that the color can get more intensified. While we have melanocytes, and we can't really change our color too much, right? So those open and closing, pigment-containing cells can change if a fish is going over light substrate. It's not good advantage to be darker over light substrate, so they might blanch out. They might change based on activity. If they're super hyper, they might be lit up, and all those patterns might show up a little bit more. If they're breeding, if they're older, if they're, male, female, a lot of different, if they're younger, a lot of different conditions, if they're alive or dead, can change with that color, right? So don't look for color, look for patterns, look for features that won't change based on conditions. Like the telltale way for scientists a lot of times is doing spine or gill raker counts. Spine and rays, you can do it, when that fish is okay and alive. Gill raker counts, you're getting inside of like the actual really sensitive portion of the gills, and if we're going to let go of that fish, we don't want to hurt them. So maybe look at these ones if it has spines or that. Mouth position, that can really tell you maybe what kind of family that fish is in. Maxilla shape, that's that little top bone on the fish's mouth. It sort of is like their top lip, that's a bone. And relative position of different things, we're going to go over some examples of that. Interopercle or operculum, that's their gill plates. Some fish have two little gill plates, like one in between that really big flap that can be either serrated or smooth. And then we have other kind of characteristics which are great. Like if you could get these, you know what it is pretty much. Barbels, those little chin whiskers. Bills, not as many fish have those. Pharyngeal jaws, you might have to, after you fillet it, really pay attention to that, which we don't want to do if we want to let go of the fish. But those are those crushing plates in the jaws. Scutes, which are, sort of bony kind of projections. Keels, suckers, hammers, all sorts of stuff. So if you get one of these, two of these, and one of those, probably have a good positive ID. If you get a couple of these kind of characteristics, maybe you get down to the family level, which can help you like, oh, that's a grouper. And instead of looking at thousands of species to identify, maybe in your local area you get 10 or 12, and that'll really help you narrow it down. So if the fish looks like a grouper, start looking at Google grouper, look at the family of grouper, look at what species are in local by us, and you can identify a fish that way. So we'll go over some examples of why color, in this case, is a really bad indicator of a positive fish ID, right? So we have 6 species of snapper here that are all red, and they all live in Florida. And normally when I do this presentation in front of a group, I have the ability to ask people, hey, guess which one? But I can't see you on the other side, so we'll tell you shortly. But like I mentioned, color can change if it's in or out of the water, shallow or deep. Red is the first color that disappears as you ascend in the wavelength in the water column, because it's the longest wavelength that we can actually see. The shortest is those blues. So think ultraviolet or infrared. Those are sort of the two outside spectrums of our visible light spectrum. They can change if they're over different colored substrate, light or dark, watercolor, light or dark, if it's tannin water or not. Not necessarily these fish, because a lot of these are offshore, but think of like that really dark colored snook or that crevalle jack you catch in the river compared to catching that same fish on the beach. Live or dead, like I mentioned, age, breeding season, all sorts of stuff can affect that. So these fish too, so we got the red snapper, the silk snapper, vermilion snapper, blackfin snapper, lane snapper, and queen snapper. Sort of where you're fishing too and time of year can be a good indicator of what are the chances you're running into a certain species. Because you can see that the vermilion snapper and the queen snapper look pretty similar, right? The same kind of relative body shape compared to these other 4 snapper, right? But, as an angler, I know that these queen snapper live in hundreds of feet of water. Well, vermilion can too, but you could catch these in maybe 80 to 120 feet, which if you catch a queen snapper in that depth, that'd be really rare. So use characteristics like that, maybe even time of year, to determine what's the likelihood I'm catching either one of these species. That can really narrow it down. So, then I said, hey, color's not good, but look at patterns, right? Patterns help out. Patterns will always sort of be there in the background. You could tell they're there. They might fade because patterns are also associated with that color, but you'll see stripes. So these 2 fish both have stripes, and they both sort of live in the same area. And they both have similar characteristics of, like, look at that pectoral fin. They're the same shape, have these stripes. If you look a little bit deeper, the sheep's head have more stripes than the black drum, but you can't really count that fast as they're flopping around on the deck. But things, once you start looking at all things, it starts making a little bit more sense. Like looking at this dorsal fin. Hey, that dorsal fin is split on the black drum and it's singular in the sheep's head. Good thing to think of. Hey, this sheep's head has a fork tail rather than this flat tail of the black drum. Tails can split. If I took a knife down this tail, I could make it a fork tail. But, that's one characteristic you match with that dorsal fin. You start getting a really good idea of what you have. Then you start looking at these unique characteristics that you don't really see in either of these species, or are pretty rare between what you even see between all the species out there. So these sheep's head have these really pronounced incisors and some crushing teeth, while a black drum's teeth, you can't really see them here, but it's just all rubber lips. They have these pharyngeal jaws meant for crushing. But if you look at this black drum's chin, it has chin barbels that are absent here, right? So those chin barbels are a characteristic for chemoreception or mechanical reception, like a catfish's whiskers. So they're going to be eating on the bottom and using those, but they're absent in the sheep's head, right? So we'll learn, why these characteristics sort of make sense. So if you have these chin barbels on the bottom, you're probably going to be feeding towards the bottom, rather than the sheep's head have a mouth that's sort of in the middle of their mouth. So they're maybe maneuvering a little bit more, feeding mid-water, feeding towards the bottom too. And by looking at these incisors and these crushing teeth, you could tell that they'll probably eat something hard. what lives mid-water in a complex kind of environment? Barnacles, So we'll go over more of an example that way. But this chin barbel actually is a good example to use when determining different drum species too. I can't tell you, I've seen my neighbor show me a big redfish that he caught. That redfish was silver. It was a big fish, probably faded out with his pigments, and it was during a time of a redfish moratorium where they were closed. And I'm like, oh man, Tony, you got the wrong fish. He's like, what do you mean? It's silver. It's the, that's not, a black, a red fish. And I'm like, oh, well, look at these chin barbels. Black drum have chin barbels while redfish don't. So that's a fun little fact there. Next up, oh, we got something that looks really similar. So what do you do when they start looking really similar as well? So these are two snappers, a cubera and a mangrove snapper. If you were here in person, I'd be judging, asking which one's which. Oftentimes people associate cubera snapper of being larger size, and they are the largest Atlantic snapper species. However, in this particular individual, the mangrove snapper is actually larger than the cubera snapper. These are really subtle differences to see, but once you start seeing a couple of these put together, it's almost like loading a picture of like that one is definitively a cubera, that one's a mangrove. So first up, the telltale way to determine is this vomarine tooth patch. So vomarine usually refers to anything in the mouth. The mangrove snapper will have a arrow-shaped one you can see right over here, while the cubera has a little W, right? But look at these teeth. Do you want to put your finger in its mouth and determine which one's which? No. And oftentimes management makes similar kind of looking fish have similar lower size limits or even the same seasons to avoid people from, having a misidentification, because they don't really want to write you a ticket. They just want to make sure that you're abiding by the fisheries regulations to help preserve our resource. So anything on the left-hand side of these two comparative pictures are going to be a cubera snapper, and anything on the right will be a mangrove snapper. So first off, after that vomarine tooth patch, you see this is that maxilla I'm talking about, that top jawbone area, right? So that cubera snapper has a pretty robust maxilla compared to that mangrove snapper. These fish, mangroves, I think the world record is probably about 20 something pounds. World record on a cubera is like 130 pounds. So think of this as being like a monster truck, and this is like a regular truck. Next up, if you start seeing the teeth of the cubera, they're a little bit more farther spaced than the mangrove. Hard to tell the difference when you have just one individual instead of comparing them, but start paying attention to that. Sometimes color and patterns can come in, but like I said, color and patterns, not that great indicator. But try to piece these together with that to really get that definitive ID. Then we have this anal fin. So this anal fin, which is right here on a cubera, is more rounded, while the mangrove snapper is more pointed. Also, there's darker pigmentation between these fin rays of the cubera snapper, and I believe that's where its species name and its scientific name is derived from, is that dark bluer kind of pigment, rather than this is more of that reddish kind of shape. So sort of that putting a lot of features together to try to paint a better picture, a more definitive picture of what it is. Next up, we have gag or black grouper, right? So these two species are very close together. Depending on where you're at in Florida, they might be open or closed during the same time. I know in the Atlantic, I believe all grouper species open May 1st. While here in the Gulf, we have seasons that might change pretty frequently. And black grouper have been historically open year-round, while gag grouper have been really restricted. So even, media gets it wrong sometimes. With this Ocala Post article says gag grouper will close for recreational harvest. I will put $100,000 that is a black grouper, and I'll show you why in a little bit. So a lot of people will say, hey, what is the telltale sign of a black grouper? Is this paintbrush tail and paintbrush dorsal fin, right? That you see in a lot of older individuals, and these nice sized fish as well. But in other areas where you see really large gag grouper, they might have that similar characteristic of paintbrush second dorsal fin, really dark pigmentation. And if you're in the Gulf, this fish might be closed during a certain time of year while this fish is open year round. So I have these two pictures here. This picture I'm actually holding two black grouper. This picture I'm holding a gag grouper and a black grouper here. And how can you tell the difference? They look really similar, right? They're in the same genus, so they don't really vary too much. This is just almost a tropical gag grouper, while gag grouper are sort of distributed more temperately compared to black grouper, which are a little bit more tropical of a fish. But I'll give you a clue of how to, determine that with these is looking for these burnt orange spots. So along the side of the fish, it might be really hard to tell because there's darker pigmentation. But where there is not very much dark pigmentation would be like the throat areas, right? Think of a great white shark, that counter shading of that bottom side being lighter than the top. Well, these pigments or these little circles sort of show up a little bit better on that bottom throat area, right? While they're absent in the black and the gag grouper. So black grouper, burnt orange spots, telltale sign. They also got little yellow creases in their mouth. Gag grouper will actually have a serrated preoperculum. That's that preoperculum. That's the operculum, and no burnt orange spots. So thing to look at. Next up, we have pompano. So who's the pompano? Like I mentioned, if I was here in person, I'd say, hey, try to guess. But we have three species of pompano and then other species of jacks. And all of these are in the Jacarangidae family, but then broken down into, those different kind of species. So we have a palmetta, we have a Florida pompano, and a permit. And oftentimes, Florida pompano and permit get mistaken, and that's an easy mistake because they're both pompanos, right? They're both in the same genus, Trachinotis. And the way you could tell the difference between these three fish compared to other species of jack is that these three fish have blind dorsal spines on their back, right? You can see they're just like little pokies rather than fin rays going through them. So it's sort of like a cobia if you ever caught a cobia before. Next up, the difference between a pompano and a permit is really hard to tell the difference of for an untrained eye, and that's why FWC oftentimes makes that lower size limit the same, because these fish won't get above maybe 10 pounds. That's a really big one, while this fish can get almost 50 pounds, right? So once you get past that 20-pound range, probably going to be a permit. But a way you could tell is that more sloping head over here. Color, like I said, is not really a good indicator, but these will be sort of darker in color sometimes unless they're on the beach, more yellow throughout, while permit have this really sort of concentrated orange spot oftentimes right by the anal fin. Ways that you could tell the difference between a pompano and a crevel jack that might have the same color scheme is this little dot over here, right? So that's a little pattern on their operculum, absent in the pompano, right? Then we have those dorsal spines here that are naked, and those have the webbing in between. And then we look at this caudal peduncle. The caudal peduncle is where the tail meets the body, right? Crevel jack will have these scoots along the side like bony projections, while these pompanos, the permit, the Florida pompano, and the palmetta are smooth over there. So little characteristics to pay attention to. And, not necessarily in just these fish, but as you're looking at fish as a whole, like look at the parts of it and see how that difference between the ones you're trying to target and the ones you might be trying to avoid. Okay, this is one that we have a little case study on, and something that I've been encountered with a couple times by different captains who might have gotten fractions and asked me to help determine if they have the right fish. So we have amberjacks. There's 4 different species of fish that are sometimes referred to as amberjacks, and they're hard to tell apart at a certain size. Once they get bigger, like I mentioned, it's what are the chances of you having an 80-pound Almaco in Florida compared to an 80-pound greater amberjack? Not as great, but Almacos other places in the world will actually get really huge, like in Japan and stuff. But Here in the States, we might see a big one being, I don't know, in Florida, 20 pounds. That's a huge one. In our area, more typical like 2 pounds, 3 pounds. But nonetheless, start looking for key characteristics like the relative difference between where this anal fin starts and the dorsal fin. These are more in line, right? While this anal fin starts way behind that dorsal fin. Same thing with these species here, right? So another thing to look at is how that body is. These are really sort of tube-like, while this one's a little bit stretched, right? And other thing is color. I know color is not a good indicator, but once you get these three characteristics mixed with the color that these are a little bit darker, this is an Almaco jack, it'll help paint that better picture of that's an Almaco compared to a lesser, a greater, or a banded rudderfish. Next, between the graders and the lessers that are really easily confused, you have to look at features like the relative position of the eye to the maxilla. These are all artistic interpretations, so something to consider as well. Or the shape of the maxilla. This is more boot shaped, and we'll go into more detail later. Fish that is, and it's really significant because greater amberjack are closed during large portions of the year here, while Almaco jacks have been open year round. Lesser amberjacks have been open as well, but they have different bag limits too. Then we have something called a banded rudderfish that a lot of people like to think that is a lesser amberjack or not a juvenile greater amberjack. And the way you could tell the difference between the banded rudderfish between the rest of these three species is they have this like lighter pigmentation on the tail, right? But if I have a fish in a cooler for a while, or if it's been dried, if that tail starts drying up, that color sort of fades on the tips. So it's not really a great indicator. But something that they have is this keel, which that caudal peduncle area where that tail connects to the body is actually a little bit raised. So it's almost a little bony kind of area, and something the other ones don't have. So start feeling the base of their tails, I guess. But we have these little guides, and I'll show you how to use them a little bit in this case study that I got. But you can see that relative position of the eye to the maxilla, where these two things might not really move compared to other kind of conditions, right? So this is an amberjack that was turned in by a captain who was asking if I could help him identify a fish because he had a ticket from FWC. So first of all, I started looking at features on this guide to see how they might fit. And this thing looked relatively smooth, right? Not really raised or boot-like this greater amberjack. So the quality of the picture wasn't too great, but trying to make sense of it for the angler itself. So that was one feature I looked at. Next up, I looked at that tail area to see, if it had a keel or if it had those white tips on there. It doesn't look like it looks like it has a pronounced ridge, but hard to tell from the quality of pictures, right? So it looked, like I mentioned, having that raised ridge that these guys have. That eye and that maxilla shape was sort of in line. So it looked like they might have had a banded rudderfish. I just wanted to show this picture because this is a lesser amberjack, which a lot of people think that a small greater amberjack is a lesser amberjack, right? But these are two distinct species. This looks like it's actually a boot-shaped kind of shape, but it's actually this maxilla that is it's sort of shaped. The mouth is open. So this bone will fit into that section of the face. So it's actually smooth over there. We look at that tail, it doesn't have a keel, so it's probably not a banded rudderfish, right? So this one was not an Almaco jack because it wasn't stretched. These two fins are far apart rather than in line. This is flat rather than booted, and it doesn't have a keel, so I'm going to say it's a lesser amberjack. And this is a better picture of a smaller one. That you can see how distinctly different they are once you have that definitive kind of example. So, we told you to look at different kind of ecological features of morphology and how that fits or solves the ecological puzzle. So we'll look at the sheep's head, sort of do that cold reading of what is this? So First of all, we study this broken pattern. So if you look at a broken pattern, that's something that might not be in the open ocean or on sand as much, because why would it have stripes? It's usually blending into like a complex kind of environment, where where are things that look like that? Bridge pilings, mangroves, all sorts of stuff. Then it has a highly compressed body, so it's not like a tube, it's not a torpedo, it's flat and sort of short. So it's going to be maneuvering around structure, sort of. It's not a fast swimmer because of that. Fast swimmers, think of barracudas, tunas, all that kind of stuff. That's really long, cylindrical, rigid. Um, then it has spines and heavy scales. So why would you evolve spines and heavy scales? Are you a predator that have spines? Probably not. A lot of prey items or things that move slower or smaller might have these really heavy spines because it's almost like a defense mechanism. And the scales, if it has that, it's going to be around sort of a habitat, right? Like a rocky or structural habitat where if it bumps into it, it has protection that way, rather than fish in the open ocean like a sailfish or marlin tuna might be, almost like skin with tiny, tiny scales. It has a terminal mouth, so that's a mouth that occurs in the middle of its body. If it was on the bottom, it would be called an inferior, and if it was on top, it would be called a superior mouth. So that mid mouth sort of shows that it eats right in front of it. So it's eating right in front of itself instead of off the bottom, although it could eat it off the bottom because fish are generalists per se, but more specially in eating right in front of it. And then it has those human-like teeth, those incisors and molars. So why would those be advantageous? Incisors, these teeth are meant for cutting, right? So, or shearing. So you're going to be shearing something, and then it has molars like us, right? And molars are meant for grinding. So you're going to be shearing and grinding. You're probably not going to be eating too many fish if you're going to be shearing and grinding down. You're going to be eating something with like an exoskeleton to crush them. That's why you evolve these kind of teeth. So by looking at those characteristics, we know what kind of habitat it is. It's in like a complex vertical kind of shape habitat because of this broken pattern of these scales, right? And the body shape, it being not like a huge long distance swimmer. We know how it's going to swim. So, where are you going to put your bait? Probably near a structure where these fish might be located. The ecological role of probably being a prey item for some things because it has these heavy kind of spines and not teeth that are like aggressive like a shark's teeth or pointy teeth meant to hold fish there, right? So maybe a little bit more passive, maybe more diurnal than nocturnal because it's a prey item. And then how it feeds. It's biting and crushing, so what it probably eats. So just by paying attention to these characteristics, we know where the fish is going to probably be around, what kind of flow, what kind of vicinity of structure, what kind of bait we could use, what kind of salinity sort of, where do these like shelly kind of things live? Maybe not so much in freshwater than in saltwater, and then sort of time of day to fish for them. So it's sort of a cool kind of skill you're like a carnival kind of guesser, like guess my age or like guess what I do for a living. Like I could guess what a fish does for a living. So next up, we're going to just sort of go over like cool kind of things that fish have, these morphological characteristics and how that relates to the ecology and, how you could keep on using that to predict fish sort of behavior almost, right? So things to consider is mouth position and gape. So if it's a bottom mouth, it's going to be eating on the bottom. If it's like a big mouth, it could be eating something that is a larger prey item, or maybe it's using it like a basket. So in that case, you might want to look at the teeth compared to that mouth gape, right? If there's like really, really heavy bones, like that sheep's head, maybe it's a big crusher, strong bite force. If it's really fragile, maybe it's more of like a shooting its mouth out to suck in food. Then you could think of as eyes, if it has big eyes, it's going to be more of a sight predator. Maybe color is more important, maybe movement's more important than maybe smell. That, features like those chin barbels or those whiskers can help taste things. Hearing and other senses to pay attention to, and we're going to go over some cool characteristics. So, like I mentioned, mouth position, these are really kind of three different mouth positions. I don't really know the subtermal as much, but inferior, sort of on the bottom, sort of middle of the face, sort of on top. So on the top, what kind of bait lives on top? Tarpon, eat crabs, shrimp, they float out with the current. Let's do that. Um, you know, if the mouth is on the bottom, this is actually a sturgeon. They eat landslets, which are like little chordates that you ever see like a Native American headdress. They're actually those white shells that go there. So they dig them up out of the sand with their sucking kind of mouth and eat them. And then if it's something that is in the middle of their face, maybe it's really utilizing its environment, going at it, being like a predatory kind of fish. Dentition, incisors, shear, canines, if they're really pointy, maybe it's more of a fish eater. So I like to think of looking at a gag compared to a red grouper. Gag grouper have really sharp kind of like pointy teeth. They're fish eaters. Red grouper have a lot of little small kind of teeth, right? So they're eating more crustaceans. They're sort of sculping and sucking down their prey a little bit more, while a gag utilizes the whole water column more and catches these bait fish. And then we have gill rakers. So actually, let me show you this video first. So that is a sling jaw wrasse, and you can see how kinetic, and kinetic is a fancy word for like how much the mouth moves. So that mouth moves really far. So that thing probably doesn't have a lot of muscles that are meant for crushing, because it's a really delicate mouth that shoots out. So it's going to be a suction kind of predator. These are pharyngeal jaws, which are these crushing plates in a black drum and red drum and a lot of other kind of fishes' mouths. Grunts actually rub these together to make that grunting sound, and they're eating, small kind of crustaceans on the reef. So if you see something like this, you know that they're eating either oysters, crustaceans, all that kind of stuff. And next up, we have gill rakers. So everybody has probably accidentally put their hands in a fish's gills and have seen the Chinese finger trap of razor blades that hurt, right? So those gills are probably a predator that's eating a larger prey item, right? While these gill rakers here, which are the white structures, not the red structures, which are meant for breathing, but this is like that white kind of cartilaginous area, are meant for sort of filtering the water, right? So if they're super fine gill rakers, it's probably eating a really small food particle and then funneling it into its mouth. If you're eating a really large food particle, like a whole fish, and it's going through here, it could get stuck or not really go through. So something with short, stubby gill rakers, more of a predator. This one more of a maybe like a algae eater or eating plankton in the bloom. And that's actually a red drum's pharyngeal jaws compared to the black drum's ones that are more flat and crushy. So next up, we have the head. You got the eyes, ears, and nose. So eyes can really help determine, how important your lure kind of presentation is, right? So eye size can determine if it's nocturnal, diurnal, if like vision is really important for a predation strategy. Seeing a black drum, they get really big. They get over like 100 pounds. They're found from like Delaware to Argentina. So, the big ones I think are up in like the sort of mid-Atlantic states. Over here, I know I've caught them up to maybe about 40 pounds or so, but depending on where you're at, they could get, certain size. But relatively speaking, black drum have small eyes compared to the rest of its body, compared to this mako shark that's like a giant ball. So probably not going to be a big sight predator. And then combined with the knowledge of that barbels, meaning, they eat on the bottom or trying to feed or find something on the bottom, will determine, hey, maybe I need to use more of a smell. And we see fish all the time in nice, clear public aquariums and in our home aquarium, but we don't really see the water that they naturally come from. And this thing might live its whole life and not really be able to see 5 feet in front of it. Determine how important the nares, which is like the nostrils for fish. We have nostrils because they connect to like our esophagus, while these nares are just sort of blind smelling sacs. Taste, if they have barbels or whiskers, can determine, hey, maybe something smelly is something I need to use for this fish. Otoliths, swim bladders, some fish have swim bladders, some fish don't have swim bladders, can determine where they are positionally in the water column or if they need to keep on moving or else they fall down and suffocate. So cobia, mackerel, tunas, they don't have swim bladders, while other fish like grouper, like that you see barotrauma can affect, they have big swim bladders. Next up, we have, movement detecting cells, whether it's a lateral line. If it has a strong, pronounced lateral line, maybe it needs that to determine where it is in the water column or bait around it. So things to look into. Tail. So tails are important and tails and body shapes, because it determines where it lives in the water column, how it moves, if it's fast, slow, body shape, all sorts of stuff, right? So let's look at the tail portion. So there's different kind of fins. There's paired fins and not paired fins. So paired fin would be these pelvic fins, pectoral fins. Unpaired fins would be the anal fin, caudal fin, and dorsal fin. So if you're looking at a guide and they say look at the dorsal fin, like there you go, there it is. But they can be fixed, which is they don't move like a shark, or they could be retractable. They could be flopping them around, or they can be undulated. So thing to consider there. Why would something be fixed, right? If it's fixed like this, it's actually reducing drag because it's not having any back and forth kind of movement. So fish like tuna or mackerel, they're pretty rigid. They're just moving one portion of their body and their torpedoes and they're going, right? And they might have those small scales to prevent drag because they're speed machines. While something that's really floppy, it might not be the fastest swimmer ever, because that whole body movement will actually, sort of not be good if you're moving for a really long time. Aspect ratio, sort of how big the tail is, so if it's a tail that looks like a sickle and has a big and top and bottom lobe, that's probably something that is, pretty rigid, pretty, meant for prolonged or burst kind of speed. It's going to be a speed demon. If it has a lobed kind of tail, it could have burst periods of speed, but it's probably meant more so for precise maneuverability around structures, right? So think of like the rounded Goliath grouper tail, or more so like a parrotfish or something, compared to maybe a bass, and then maybe like a swordfish or a sailfish. Then there's ones called homocircle tails or heterocircle tails. So homo means the same, top, bottom, same, homocircle. Then you start getting into the heterocircle, which something's different. So if that forked tail is uneven on the bottom, probably going to be something that swims toward the surface like a flying fish. If it's bigger on the top like a shark, probably something that's swimming down on the bottom. So think of how you're going to present your bait in those kind of situations, between something that hangs out on top or something that you want to target that hangs out on the bottom. Okay, so there's a lot of different kind of shapes of fish. Like I mentioned, there's like 29,000 different species. There's about equally the same amount of freshwater species and saltwater species of fish, right? Because each little pond, puddle, river can be a place where evolution occurred. That is not like the open ocean, where there's a lot of intermixing in the same fish over here. Like I mentioned, the black drum can be found from North America to South America because it just sort of found its way, swimming the ocean. It's all connected. So torpedo, might be more of like a burst kind of mid-water body thing. But if it's flat, you're not going to really see the mid-water column. So think of the flatfish, stingrays, flounders being on the bottom, and then how that has changed in between from the two extremes. If you look at the body, if it's really reflective, it might be something that lives in the middle of water over a light kind of substrate where, looking like a mirror can help you sort of blend into sort of a really light kind of environment. If it's counter shaded, like a lot of fish are, that's sort of preventing them from being spotted from the top down. If it's darker, a fish or predator looking from the down. And if it's lighter on the bottom, when you're looking up from the water, it's going to look sort of like the sky. Fins to pay attention to, it went over that on the previous slide. Patterns, can help you determine, where that fish fits ecologically. It has a lot of stripes, might be something that lives around structure that is, sort of up and down. So next up, we're going to go in, and then if it has scales, it might be something living next to this heavy kind of structure where it's good to have armor. If it has spines, maybe the same thing. Maybe it's like a prey item where if you're spiky, you have less of a chance of getting eaten by a predator. So how would you fish for a prey item versus more of a predator kind of species? So things that can affect the bite. Biological kind of characteristics, life stages, size of the animal, spawning, geographic distribution, migration routes. The panhandle, they have okay fishing, but sometimes they have really great fishing, just depending on those migrations. So, if everybody's catching cobia and you catch something that looks like a cobia because of their migration, maybe it's that. But maybe start looking at those other kind of features and say, hey, that cobia has a sucker on its head. No, that's a remora then. So prey availability might be a thing. If there's a lot of bait around, might be more predators. If there's a lot of predators around, that fish might be tucked into like the structure. So you might fish closer to the structure because that fish might not feel safe out in the open. Algae blooms, internal anatomy, and then biological kind of considerations that might affect life stages. So I have a good example here of that is a little paper that I read about snook. So snook spawn between May through October. What kind of fish spawn? Usually the large adult fish, right? So if you want to catch a large adult fish, May through October, focusing on where these fish might be. Peak spawnings in June, July, and they go out to like deep water passes or near shore artificial reefs might be your best chance of getting one of these monsters, right? So by just looking at that life history characteristics, we can sort of better adjust our approach to get the size of fish that we want. Other things like salinity might affect it. Certain times of the year, other fish might be going up in the floodplains to spawn with the rain. So think of an alligator gar, which we actually don't have very many in Florida. They're mostly restricted to the panhandle west of the Escambia River. They're more of a Texas, Louisiana kind of fish, but they like to go in the flooded areas and lay their eggs. So something to consider for that. Dissolved oxygen, if there's a lot of dissolved oxygen, that might trigger more of a response to feed rather than if it's no oxygen. These fish are just trying to stay alive, so they might not be as hungry then. So these are little diurnal oxygen cycles. Might not change so much in the open ocean or in areas that have a lot of water mixing, but think of like the back bay kind of thing. So the lowest amount of oxygen, if you're in a pond or any place like that, will be right before the sun comes up, because that is the longest period of darkness. And oftentimes primary production, these algae, these plants photosynthesizing is how most of the oxygen get into the water in these systems. So, that lowest dissolved oxygen level might make some bait more vulnerable, or might make the predators like a little bit more active as that oxygen's coming up, right? So, oftentimes I like to focus on where change is occurring, because that like little rift section is like a really good place to get fish that are either trying to take advantage of that or trying to escape that, which feeding might happen. Think salt freshwater mixing, think different kind of conditions, tides, all that stuff. So tips and tricks. We can use comparative biology, like I mentioned, like comparing different kind of fish shapes with the one you want to target, might have similar kind of approach of targeting that fish. You can use stock assessments. These are all free papers online that go heavily into biological information, diet composition, size, where they're at. Free for the public. Check them out. They're really interesting. If you have a favorite fish, I would look into them. Scientific papers, go to Google Scholar and type in any kind of fish that you want, and there's probably a paper on it that could help you be a better angler. Commercial catch data, FWC publishes the commercial catch summaries every year. You can filter it by species, by area, by county, by a whole bunch of different stuff. So, for me, I like looking at, hey, if I want to target pompano, let me see where the highest catch rates of pompano were in my area in the state. And I see February and March having the highest amount of landings by the commercial sector. So if I'm going to try to target pompano, I'm going to probably listen to the guys that, do it for the living. So I'd probably, catch them during that time or try to catch them more so then than maybe in the middle of the summer. Using your own catch data is important too that you can use. Like this picture is September 2017. Man, I'm getting old. But I got a nice Cubera snapper there. And then I looked at another picture that I got a nice Cubera snapper one time, and I saw that it was also in April. And then I got another one, it was also in April. So you're building up a data repository yourself. So look at your fish pictures and see what days you did really well and see if you could think of some patterns between that time of year, time of day, all sorts of stuff where you had higher success. And then there's a lot of data out there available from maps. You could use Google Maps and see darker areas so you're not fishing like in 1 foot of water when there's 10 feet right next to it. Or just environmental kind of condition maps where you can see salinity or dissolved oxygen in particular areas. There's lots of research stations out there. And it's called fishing, not catching. Even though I look like the guru that I am here talking about how I can read a fish's mind, sometimes I don't do as well, right? So I can understand a fish, but you can't make them eat a lot of the times. But by paying attention to this, you have a better shot than maybe the average angler who doesn't know what they're doing. So it's up to everybody to do their part. There's a lot of best practices out there. If you're catching a lot of fish that might be undersized or over the size or out of season, or you already have your limit, maybe consider moving to a different place and targeting another species. So you're not putting on pressure on a resource that might have a lot of pressure on it. So think a red snapper. If you're going out there and it's not season and you're letting a bunch of them float off because you didn't bring your descending or venting tool, which you need to have on board, you don't want to see those fish die. You want to be able to catch them year after year. So maybe consider moving. Have a plan for your fish. So before you go out there, say, hey, we're going to keep fish today. I want to keep red fish that are over 20 inches, right? So when you're getting them, you're not stressing them out by keeping them out of the water for a long time. You know what you want to do with that fish before you even get it. And, if you keep on catching the same fish and you're already done taking your pictures, maybe stuff like using a dehooking device to limit your contact with the external side of the fish, that can help with survival. Holding a fish correctly is important. See a lot of people holding big bucket mouth bass this way, or snook by their jaw. But the way they feed, they don't have teeth. They open their mouth really quick and they swallow the prey. So opening their mouth really quick and swallowing prey means they probably don't have really big jaw muscles in there because they got to be really kinetic like that. So by holding them by the bottom jaw, you might be dislocating their bottom jaw. And that fish can swim away, but who knows if he's going to starve in a couple of months because his mouth can't really open correctly. And that's sort of what they found with tarpon when they did the bottom jaw gaff of that affected their feeding. Even though that fish swam away, it might have died a couple weeks or months later after that tournament and that fish was caught. Using circle hooks is a good example. It's required in a lot of places. Don't lay the fish down on a hot surface. Cut the line if it's gut hook. Don't play dentist, on a fish. Use knotless rubberized nets to avoid, taking that slime coat. That's like a sense of their immunity. Using descending devices and venting equipment, and making sure you have like the correct size of gear. So reducing fight time can help them recover better. And I'm not saying to adopt all these practices, but if you do some of them, it's better than nothing. So, a little side plug, we have the Florida Friendly Angler program. So this is a free online program. If you liked, what you heard today and you want some more information, that goes over environmental ethics, best catch and release practices, and fisheries regulations. Everybody wants to know what goes into the secret sauce of why red snapper season is the way it is, and this will go over a little bit of fisheries management. So it's an hour and a half long. It's due at your own pace. It's free. It is all narrated, has plenty of supplemental information and videos. So you just click play, sit back, listen, and enjoy the activities when they pop up. So you can find that by going to flfriendlyangler.com, and I'll actually tell Sam to send you an email that has some links to the program as well. So it's a great program, and we just actually finished the Spanish translation of the course, which happened about a month ago. So it's fresh off the press, and there's not too many resources out there for Spanish-speaking anglers, so we hope that it gets used. So, I'd like to take this time to answer any questions you guys might have. This is my contact information. That's me holding a big Arapaima, actually, during grad school. I'd be happy to answer any questions you have. And check out us on social media and our links that we have that will pop up on a Linktree link, a QR code that you'll see on the right. And my whole job really depends on if you guys have learned something, and if you valued it, if you want to modify your behavior positively somehow. And I would really appreciate if you take that quick, scan that QR code on your phone and take a quick evaluation. Helps us determine if we effectively reached you, if there's more information you want covered, as well as I have 2 questions regarding freshwater fish consumption, because I do a lot of invasive species programs, and we're surveying anglers to see if you've eaten a freshwater invasive fish species, and if so, why or why not, and what species you did eat. So that would help me out a lot, and I would help you out if you send me an email. So this other QR code is actually for a Linktree that has a lot of the links that I mentioned, a lot of the programs I mentioned during today's talk. So please, if you're interested in my programs, go ahead and scan that QR code. It has statewide online kind of programs, more local ones here. I could help you get connected to your local sea grant agent if you're in a different part of Florida. And thanks for listening to my talk today, guys, and hope you guys learned something about it, about fish ecology and morphology.
Mike, man, awesome. I've been excited about this, and you just tore it up. And I literally have so many notes on my phone right now of things that I didn't know or things I didn't even think about. While we're waiting for some questions to come in, yeah, I'm just blown away. I'm just going to highlight a few things. We'll get into the questions, and then I'll highlight a few more things coming back. But one of the things that I never thought about was with heavy scales. I know redfish have heavy scales. Black drums, different things have heavy scales. And when I catch Jack Crevalle, depending on how you say it, they don't have those scales, right? They're smooth, like you said. And I never thought about that. It's because those reds or those different fish or sheephead are round structures, so they want to have protection. I did know like the difference between looking at a jack and a pompano. Clear as day, I can look at it. I know as well as the jack, the way the Jack Crevalle's where the head is, it's a longer kind of head, but it's like almost like a bull. And I know they will use that head to run and smash bait to try to, dislodge them and mess them up too as well. So yeah, man, it's some really cool and good things that you said. So as far as questions, we have how many fish can a swordfish eat during one feeding period?
That's hard to really determine because it depends on the size of the swordfish and the size of the fish that they're eating. You know, if it's a small lanternfish that and a swordfish that weighs a couple 100 pounds, that might be hundreds of small little fish, right? You know, I've also seen other kind of billfish like a blue marlin eat a tuna that might be 40, 50 pounds. So swordfish, they're definitely fish eaters, but what else that lives down there too are squid. So they're big squid eaters as well. So the very few I've interacted with had not that many fish inside it, but a lot more squid. So there's not a really good answer for that, but I like that. I like that question because it brings up another kind of unique characteristic with a swordfish that they, like I mentioned, some fish are warm-blooded, and it's not like their blood's like 98.6 degrees like us, but these fish might be 2, 3, 4, 5, 10 degrees above ambient temperature, which helps them perform better. It's advantageous for us to think faster, sort of move faster if we're cold, if we're actually like a little bit warmer blooded, right? So swordfish have these modified muscles around the eyes that vibrate and make their eyes actually perform a little bit better because they're warmer, and that's a cool feature of them. I actually have an eye in a jar over here.
Yeah, sweet. Please show us.
So this thing is about the size of a baseball, and it's a swordfish eye. And you can see if it has its eye is really big. What's that telling you about the presentation, right? It's probably better of a visual presentation than you know, a smell or something like that. So that's why people might have really long, bright colored kind of baits or those flashing lights on there because this is basically a umbrella to suck in as much light as possible and outcompete its prey.
Wow. Wow, that's crazy. That number one is crazy that you have that in there.
Yeah,
Sitting there. Yeah. And number two is it's just those things like believe it or not, I actually learned a lot from about Fish ID that I never looked at by actually our local Florida Sea Grant agent that's in St. Johns County.
Mhm.
And she taught me a lot because I never looked at fish like that, like based on their eyes, like you were saying, based on where their mouth is located. That can tell you what part of the water column that fish may feed in or may live in. So that again, you went over that, and it's just something that you never think about. And I love studying fish. Like when I catch them now, I literally take a few seconds, study the fish, look at different things, and then let them go. Of course, I'll take pictures and stuff as well, so I can go back and look at it later. But the colors is just beautiful, and just the body of the fish itself. So we
Mhm.
have another question. Is there any model to tell you if the fish is poisonous?
Mhm. That's hard. Okay, so um, poisonous is one thing, venomous is another thing, right? So
Mm,
poisonous is sort of diffuses through membranes, right? So think of poison dart frogs. You have to sort of touch it, right? Or you have to consume it. So poisonous mushrooms like poison hazard, right? While venom is more of something that stings or bites or has to get past that through like injection or a bite. So not many animals are actually poisonous, right? Like toads and slow moving things might be poisonous, but there might be more venomous kind of fish, right? Like lionfish with venomous spines or scorpion fish. As far as I know, I don't know of any fish that are particularly poisonous besides like the puffer fish and stuff.
mm,
If you're thinking about what fish is poisonous, think of like a toad. Why is a toad poisonous? It's not really running away that fast. It doesn't have any good defense mechanisms. So it's gonna have that poison to be like, I hope that thing knows not to eat me, right? And think of what kind of fish is like that. So like boxfish, burrfish, pufferfish, you know, thinking of that tetrodotoxin or something,
mm.
fugu. So I would say probably the slow moving fish that look like they don't really have a chance to survive might be poisonous because that is their defense mechanism instead of like spines or being able to run fast or something like that. So I'd say most fish are edible to some degree. Some fish might not taste great, but the amount of poisonous fish out there might only be dozens of them instead of like thousands or hundreds of them.
Wow, that's a great definition to think about. That's true. How whether in the water or on land, it's a lot of similarities, right? With animals. Like I love how you say, well, yeah, a frog mostly or a snake will try to eat it or something like that, and it gets the poison in it. It can kill over and die. The same thing with fish in the water, and then the same thing about the spiky. I think about pinfish, right? You never want to grab a pinfish because those things will get you if you don't know how to grab it right. The same thing with a brim, right, or a
Big
panfish,
prey item.
and
Yeah.
yeah. So again, these are things that you're IDing and reading the body to help you identify where that fish is. And I hope anglers and even people that are not anglers are just interested take this in because it literally tells a story. That animal body tells a story, and I'm just thinking like, wow, how I feel like I'm already a better angler by a few. Like I got more than a few, but some tips you brought out to me that I never thought about, which is amazing. It's
No,
amazing.
it's fun. I had a fun time doing my zoology classes because you could relate
Yes.
it to anything. There's a lot of cool stuff you can relate on the inside too, but you don't want to get on the inside if you can't do a positive idea on the outside. So,
Yeah.
looking at intestinal length might determine what they eat. If they have a long intestine, that's low nutrient fuel food because it has to travel through a whole bunch of stuff, and you're trying to get as much nutrients as possible. If you're looking at a short intestine, that's probably going to be a really high density kind of food item like meat. So, like a mullet has really long intestines, while something like a shark might have smaller ones, but they have other kind of cool characteristics too.
Yeah, that's awesome. It's awesome you brought that up because you can take that same comparison with a human and a lion
Mhm.
or a scavenger, right? They have those short intestines. We have long intestines, right? So they get their one meal, they sit on it for a while, where we can continue to eat things and get rid of them.
Yeah.
That's awesome. We have another question is what kind of fish is a electric fish? Do we have electric fish?
Electric fish. So there, most of the electric fish that I've seen, there's electric eels that live in
Hmm.
like South American and probably places in Africa. A lot of places, like those ecological niches have evolved similar kind of fish in those areas. So I have something called a green tree python, and that evolved in Asia. And then there's one that looks exactly the same almost called an emerald tree boa in South America. So I can't remember if there's African electric eels, but I definitely know that there's South American ones. And those are freshwater. Don't know of any saltwater electric eels, but there could be one in the 29,000. In saltwater, there is torpedo rays. And these are for stingrays that are a little bit more chubby looking. They have like a little bit of a dorsal kind of fin on their back tail area. And like if you look at the muscle stacks, I think they're shaped like a hexagon that like sort of charges them up a little bit different than typical myomeres or those muscle strands of a fish that look like a little like W or like a V. Then there's some fish that might like have mild kind of electric current, but not going to shock you. There's a group of an order of fish I think called the gymnotiformes. Really complicated name, but these are like your knife fish, your elephant fish. That like I said, like we put them in nice clear aquariums, but they live in an area that might be super dark, like
Gotcha.
at the middle of like the Congo or something where they can't see a second through them. So they might like use like little electrical pulses to communicate that way and to make like a picture of what's around them. And I think some of those fish, like the elephant fish and other kind of momyrids and gymnotiformes, big words over there, actually,
Hmm.
I think have one of the largest part of the brain proportionally to their size to like orientate themselves in like the environment.
Wow.
So there's fish that have features way more advanced than us, and then there's features that have the fish that have features way more primitive than us, and that's really neat to see how life evolved.
Yeah, it's endless. You
Mhm.
know, it's so many species and so many things. I just think about in our area, right? And just in the well, you're in the Gulf, I'm in the Atlantic, just all the different species of fish and how they communicate. And you know, I think as you get deeper into the scientific side of it, it naturally makes you a better angler, but at the same time, it naturally um, helps you want to protect, do a lot of more catch and release than you know, harvesting those fish. Like we tell people, like, yeah, we can catch fish. There's nothing wrong with that, but we can also let them go, especially the big adults that are breeding and I mean like migrating and doing those things right and spawning. You go to restaurants. We got some great restaurants around here, right? To
Mhm.
help support them and the commercial fishermen too as well. So that's good things to know too as well. You brought up something that I learned, and I'm glad you brought up is dissolved oxygen. No one thinks about that, right? The
Mhm.
dissolved oxygen is huge based on what the fish is, the time of year, right? We know in the summertime, uh, dissolved oxygen in the back of the creeks are limited, right? Here in Northeast Florida, and especially Jacksonville area, St. Augustine, you know, that side, we get those mud flats, and those things warm up in the summer, right? They're a radiator, they're a heater, so that the oxygen is less. So a lot of
Mhm.
fish move naturally towards the inlet. While the inlet, it's a lot of water moving. There's cool, there could be cooler water coming in too, like that. And a lot of times you catch those fish there. And you brought up looking at scientific data, right? NOAA puts things out there. You guys put things out there. That is going to help you too as well figure out those seasons. So I'm glad you mentioned that. That's huge.
The dissolved oxygen thing's pretty cool too, because if there's a lack of dissolved oxygen, if you're a little kind of animal, maybe you like going there. Because can a big predator function in an area that has like it's breathing through a pillow? Probably
Hmm.
not. So that's why
Yeah,
these back bays and estuaries are important habitats for juvenile fish. Like I saw a little lemon shark back in the back day.
yeah,
His mama or dad or his uncle who might want to maybe even consider eating them can't
yeah.
function back there, but those
No,
fish are. So that dissolved oxygen, not good to be zero, but that gradient is sort of helps certain species survive sometimes. Like there's squid that will actually like live in hypoxic conditions in like the middle
wow,
water column or in the middle of the ocean because tuna and sharks and billfish can't live in this kind of area, and
wow.
like their metabolism actually changes from like a aerobic to anaerobic metabolism, which is really interesting. And then they have to like pay that sort of metabolic deficit by
Hmm.
going to oxygen areas later on.
Wow.
So really cool things that happen in the animal world. Everything's chemistry, everything
It
is
is.
structure and function.
It is. Yeah, you're right. You know, the things that you can find in the back country, right, in the estuaries is crazy. Like you're like, man, this fish is gonna grow up to be offshore, like, you know, this huge fish. What is it doing back here? And then you start to appreciate. Then you get to the point of, oh my gosh, you know, we're thinking about you know, there's homes, there are different things that's on the water where you put chemicals in your yard, all that stuff to wash off. How those chemicals can get in there can kill. We all touch each other somehow, whether it's animal and people, we touch each other somehow. So
And it's a
I think
balance too.
humans help each other. Yes.
Because
Yes.
algae isn't a bad thing. Algae
Mm-mm.
is the reason why we're here. Like you can
Yes.
determine where oxygen came into our atmosphere probably because some blue green algae just started like breathing. And like they have
Mm-hmm.
areas in like Australia where I think they can see like a rust layer in
Wow.
like a stratified layer where it's like rust needs oxygen to develop, and they're like this is when oxygen came into our atmosphere. Eutrophication, more algae in the water, could be an okay thing in some areas because that supports life. All those filter feeders, all those
Right.
crabs, all those plankton things eat it. But when there's too much of that algae in the water, algae don't make oxygen at nighttime. They breathe. And they could drop that DO at nighttime and then create bad conditions, the day after, the day after that. Or if there's too much algae, maybe they provide an area where the light can't penetrate fully to the bottom, kill our seagrass beds that, are really sort of helping support huge food webs. Seagrasses next to oysters and mangroves are some of the most productive kind of habitats we have here.
Yeah, that's awesome, man. That's, just thanks for sharing that. And I'm going to close it out with one more question. I think I understand this. The question was like, what do they do during cold weather and hot weather? And I guess in the ICW area, what do the fish do? They say go deeper on, go shower. I'm going to take it as this, based on the weather, hot and cold, what the fish do. And I'm guessing that during the shower time, especially around the ICW, do the fish go deeper? Do they go deeper during the shower time, or do they stay around? I know that a fish in the water, water really, and this is mine. I know it really doesn't affect them,
Mm-hmm.
except for kind of after when they get into the wash off, different insects, things like that come into the water. That can be an amazing time to go fishing right after a shower in the front go through. But I'm gonna let you answer that question, Mike.
Sure. And I know there's actually some papers, I can't remember exactly, but there's cool kind of, they call it, if you want to be like really, scientific,
Do it.
stochastic events. So that's like events that happen that are like, oh, it just happened now. It's like something you can't really account for that much. So like when hurricanes come and we have a lot of fish that are tagged and there's a lot of receivers in the water and all those fish start moving, we could do a cool paper on like where do fish go in hurricanes. I know there's one out there, but I can't quote exactly what happened there. But other things to consider is maybe how I don't know how smart the fish is, but like what is like their home range, right?
Right.
So are they
Right.
stuck to structure or do they move around a lot? Because that might like make them like, oh, if the water is really cold and this fish has a really big association with habitat or that particular structure, he might die, like because he didn't move because he wasn't like that, right? With like maybe algae blooms too, like red tide comes through. Maybe red grouper are more impacted than maybe gag grouper because these gag grouper move while these red grouper have these holes that they might have been digging out for years and years and years. So when that low dissolved oxygen hypoxic condition comes or that brevetoxin comes, these fish that don't naturally migrate might stay still, get whacked, and other fish might be moving around. So stuff we're trying to figure out with research too. And I'm part of a red tide group that we're going to be surveying anglers when red tide does occur to see, hey, fish are dying, but which fish are dying? What size of fish are dying? And that might help paint a better model for fisheries management. A lot of people like to say, hey, I don't want to give information to fisheries management.
Yep.
But oftentimes, if they don't have the information, they're going to be way more conservative too.
Yeah.
So by having more information, we could paint a more accurate picture for, preserving our resources.
Man, I'm glad you said that. And this is something we're going to close on. When you see those emails that come from FWC or from the University of Florida or any other places asking, have you caught this? Have you seen this? How is the fishing in your area? Please respond to them, because based off those questionnaires, and then if they see you at the boat ramp, based on the data that they get, is how a lot of times they make their rules or make their I guess their analysis or the results of their research, and they hand it whether to the FWC commissioners, whether to the University of Florida, or whether to NOAA, to see if we need to open or close the season. It is super important that you respond to that. That's something that I learned. I work with FWC, and that was something that I didn't know was as crucial as possible. But I was like, okay, I need to answer everyone that comes through, right? Also, being that I'm saying that, make sure that you do the survey, please, that Mike is asking you to do, because he has helped us and blessed us so much with information that opens us up to make us become not only better anglers, but better conservationists, right? And also, I know we want to see Mike again and get him back on here, because he has so much stuff that he does and that he teaches that we want to keep learning from him. We want to show him that we appreciate him by doing those surveys. The other thing too, if you have not, you need to go and take the Florida fishing, so the Florida friendly. So Mike, make sure I say this right.
Mhm.
The
Florida
Florida
friendly.
friendly angler,
Mhm.
correct course. I took the Florida friendly guide course, which is amazing, and I learned stuff from that. And I'm super excited about taking that course. But make sure you do it because it's free. You learn a lot. They teach you a lot in there, and again, it's more education. Um, Okay. The last thing, I think I hit everything. Mike, yep, I got that. Oh yeah, best practices. It's going to teach you about best practices, circle hook, handling them. Yes, the jaw, putting in the gills, very important not to do. Want to have them around for generations to come. And then with that, I want to just thank our sponsors and partners. I want to thank Florida Sea Grant, the University of Florida, IFAS Extension, Keep St. Johns County Beautiful, and RMAC Media Group for putting this all together and the media part for this and making it look so good. And the biggest thing, I just want to say thank you again, Mike, for taking time out of your busy schedule. I know this is your busy season to do this awesome webinar about fish ID and ecology, man. Thank you so much. I owe you. I will see you this summer and we're going to have fun. So anything, Mike, you want to say, I'm going to let you say it and then we're going to get out of here and give people their time back.
Sure. And just, aside on that fisheries management side, like they'll admit it's not perfect, but, with more input, the better it can be. And, there's so much transparency in the fisheries management process. All that kind of information and decision making is posted online. There's commission meetings, there's ways to get involved, sit on panels and stuff. So if you think you have, something to say about it, show up to a commission meeting and let them know. And have fun out there. Like this is something that we're all passionate about, and share the information with others to make as much of an impact as we can.
Yeah, definitely. And when you give I will give you this tip too. If you go and I know we're all passionate. If you go and speak to them in a respectful way. Don't go arguing. Don't go mad and stuff because it doesn't go anywhere. I can promise you that. If you go respectful, they listen, they want to learn. It'll work out a lot better for you. So, guys, that is it. I know me and Mike can go all night long, but we're not. He has a family. I have a family, and then you guys probably have family too as well. So make sure to look for your email with the information I'm going to send you. If you have not, we are working hard to get to 1,000 followers on Instagram. We really need this to be able to push our mission, our message to a lot more people, and that opens up a lot more things for us that we can do. So good night, everyone. Have a blessed night, and we will see you next time for our next webinar, and we'll see you guys later. Bye.
See you.